Hey everyone, welcome to the stream. So yeah, this is my first stream where I am now a Twitch affiliate. So I announced that on Twitter this weekend. Yeah, so I actually made the affiliate program on Twitch, which is pretty cool. So thank you very much to all my followers and to everyone who supported me. So yeah, last stream we were looking at different CPU bugs. Let me see here. Where were we? Yeah, thanks, Lisp Gamer. So yeah, since last week I just went through and oh yeah, that's right. So last Wednesday we had gone and fixed a few more bugs on the CPU. I think we had re-implemented add and subtract so that the half carry gets computed. So that's to match closer to the Vectrex. I actually fixed another bug related to that, which was there was a bug where subtract and subtract with carry were not being computed properly when carry was set. So I fixed that, and I went through the compatibility list and kind of revisited some games to see if these fixes, what the results were, and we actually got a couple of games working that weren't working before. So let me try to bring up the diff here. I also did some comparisons to see if like the bad behavior that was there continued with Vectrex, and that's where the Vectrex same here comes in. So yeah, let's see here. Trying to look for where things became berserk, valid read. Oh yeah, so here we go, Hyperchase. So Hyperchase was a game that would not work properly. I said no crash, but can only drive straight. There were no NPCs or anything. Since our fixes, actually Hyperchase now pretty much works. So I can show that off. I think it's pretty fun to see. Let's see, here's Hyperchase. So yeah, this is Hyperchase. Basically, it's a racing car game. You can control which gear you're in, up to 4 gears. You know what? I should play this one with a controller because with the digital, like non-analog input, it really does not work very well. Because I'm either full throttle left, full throttle right, but actually this game does read the analog stick to set your relative position to the center. So let me just pop this in here. Got my controller. All right. Okay, so yeah, there we go. Very, very finicky. Move my mouse. So this is a pretty cool game. I actually owned this game on my actual Vectrex, and I always thought it was pretty cool. I just love like the smooth 3D kind of parallel perspective you get here. The trees, and this is really impressive. Keeping in mind that this was in 1983 or so. Yeah, I own a Vectrex, and I've shown it once on stream, like early on there. I actually pulled it out and I just showed the hardware, but I want to do like a stream where I connect it and I have a proper webcam on the screen and just kind of show how it looks and how it works and stuff. So yeah, so this game actually works. I don't know how they did the scaling, but I assume it's tables. I mean, you mean like for like storing the different sizes? Yeah, I think those it looks like it would be tables. But there are different tricks you can use when you're when you're drawing. So I'm not sure exactly. But yeah, it looks like it. It looks like it's probably some tables going on there. Just to kind of like, they have like probably a draw tree function, and you know, they probably just set the scale parameter, and I'm not sure. Because I mean, it's not, obviously it's not sprites, right? So yeah, it gives a really nice 3D look. I'll show you a game, another game that worked now much better than last time. It's worth looking at. So let me see here. Oh yeah, so here, narrow escape. Now it works. So narrow escape, let's try that. Okay, so yeah, this is actually a game that I kind of suck at because I can't quite get the perspective right. I keep crashing into walls. See, like there, I don't know why I crashed. That sounds cool, Lisp Gamer. See, like why do I crash there? I don't know. I don't really see it. I don't know. So yeah, this one looks pretty cool. Let's see, I have another one here. So pole position. Oh yeah, so I renamed some of these. I added this analog no center when the input, I have a few like this where the input seems to not remain centered when I'm not pressing it. It either goes to the left or to the right. So there's a bug there related to the way my input comparator stuff is working, so I have to look at that. Yeah, so Spinball, we took a look. This is one that went from not working or zooms in too much and then had invalid reads. This now works, as we saw. Starhawk, yeah, this is not working. The analog no center, but where is that game? Oh, maybe I didn't update I didn't update this thing, but there is, I think it's this one, Fortress of Narzad. I think I had written great, but it was actually not great because I didn't know how it really was supposed to work. I think it's this one. This game is kind of neat. Just love like the ideas they were allowing themselves to come up with. Like they come up with these crazy ideas to implement on a vector-based display. Okay, so let's see this one. Oh no, sorry, not this one. What's that one I'm thinking about? There's a game where you're a character and you're walking around and there are like treasure chests and there are caves. Let me see. So the overlays are just files that some people have made. So like they're here. So there are a bunch of PNG files. So like, you know, like this one, and they have alpha in them. So I just basically load them and blend them on top. I have a shader that just basically modulates by the alpha. So these are all the overlays that are available, and then I have this kind of fuzzy matching little function I wrote that kind of looks at the names and tries to match them as best as possible to the names of the ROMs, because I don't have like a lookup table and there's no like official. You can see that for Vectrex, you know, the scene and emulation and all that, it's not as mature, let's say, or as serious, I guess, as let's say for NES, Super NES and all that, where like, you know, you'll have databases of the CRCs for every single ROM, and you can validate that a ROM hasn't been hacked and all that. Yeah, so someone scanned them. Yeah, it looks like someone would have scanned them. And they're not even, they're all different sizes too. Like the dimensions are different. Some of them are even like different aspect ratios. even though, you know, all the overlays have to be the same. But yeah. And then some are custom, like people made their own. Have like 4 for Mindstorm here, even though they're all the same. Yeah. But I would like to get, I don't think this is a, you know, this is clearly not a complete set, because I'm missing some for some of the original games. And I don't know exactly where I can get all of them. I'll have to look or ask some people. So the game, Star Castle, could it be? Maybe it's Star Castle or Star, I don't know, let's see. Or no, Star, it was. Oh no, I don't think it's this one. No, it's definitely not this one. What's this one again? Oh, I think this is a... Yeah, it's another cool game. A lot of cool games. Star Hawk? No. I can't remember. There's one where you're a dude walking and there's chests. Somebody watching the stream later will tell me what it is. Oh wait, Dark Tower? Is that it? Oh yeah, okay, this is it. Did I not have Dark Tower in my list? Oh, it's because it's a commercially unreleased ROM. See, and I had written good, not sure, but that's because it wasn't working properly, and now it seems to be working properly. So let's check this out. You're first warrior, and you basically can walk. And you see there's, you can, your score is 0, player inventory, 5 reserved troops, 2 bags of gold. And you can open this, and then I get something wrong here. Yeah, I get this assertion where I'm expecting DDR for A to be either all zeros or all ones. This is my VIA chip. I could probably just remove this, but there you go. So if I skip enough of those exceptions, see, there's these monsters that like throw these stars at you. Is there a battle zone? Oh, you think you saw battle zone? Maybe. Battlezone demo. So somebody wrote a Battlezone demo. Let me just skip all of these again. Okay, so basically, there we go. I've got one. There's like these bad dudes hiding behind these columns. Isn't that a cool game? Replacement Warrior. I find this game really neat. This I don't know though. I guess that was part of the game. You're asking, the original was 6502 but support hardware for math. I was wondering if there is a math chip. The coolest part is the clipping of the monster behind the layers. Yeah. There isn't a math chip. It's really just the 6809. There's no like coprocessor or anything like that. Oh, what's this? Be gone. I don't know what just happened there. Yeah, so it's clever tables, yeah, for sure. Oh, I'm gonna be whisked away. Oh, what's this? Nothing? So look, yeah, I don't know, you basically walk around, and I guess you're trying to maximize your score. Oh, I just found 2 lives, 2 new warriors, 3 reserves troops, 2 bags of gold, and I have 575 of score. Looks like we're back in cave. Whoa. Alright. So yeah, very cool game. Alright, so now I'm back to actually getting some stuff to work. One thing I decided to start doing is taking the games that are considered good and running them with the 2 CPUs and seeing if we can find more inconsistencies. So let's say, for instance, like if we go back to our list, let's bring it up here. Okay. So for example, if we take Armor Attack, right, which is supposed to be a game that works well, if I run this with the 2 again and we look for a desync, do we get a desync, right? So let's try that. Armor Attack. So we say here Vectrexy server on that. And go to client. Wow. It is crazy slow when I'm on stream. Let me see my CPU usage. Yeah. I'm at like a 98% CPU usage on my machine. Oh, we actually got a mismatch? That's, oh no, it's because one crashed. Why did we crash? Super strange. Let me see something. I did make some silly changes here, but I don't think these matter. Let me see. Okay, I'll just reset this. Just in case. I tried to do some timing changes to see if I could get some better timing in there. And let me build the other one as well. Okay, so I'm just building the 2 versions again. I did upgrade my compiler since, so I don't think I rebuilt both with the new compiler, so let me just make sure everything is exactly the same. so that built the Vectrex one. And this is not Vectrex. Okay. So let me try this again. So we run armor attack here. Okay, that's more normal, I think. Yeah. Yeah, and I just updated the latest version of Visual Studio. You know, they keep updating the compiler. So this is the armor attack. They're the tank game. Oh, focused on the wrong one here. You build on a Mac. You know, Microsoft now has a product that they call Visual Studio for Mac, right? But it's actually not Visual Studio. See that this game seems to be working fine on both. Let me just see if I remove this. Is this why it wasn't working? If I remove my clamping of frame time, I'm just really curious. Yeah, exactly. Xamarin Studio that they renamed. But no C++? Oh, okay. So it's just C#. Yeah, it's for like Android and iOS and stuff. Have you tried VS Code? Okay, so it really is that. When I don't clamp it, it ends up going to this like... Yeah, I got a clamp. Okay. That's fine. You like Visual Studio Code, but it's cancer? What do you mean, like in terms of performance and memory or something? Yeah, that's true. But it is nice. And it's nice that it works on, like this is VS Code. It's nice that it works on the three main platforms there, Windows, Mac, Linux. Oh yeah, your battery life. Yeah, it's true. If you're running on laptop, I guess you have to be careful. But I like the interface a lot, and I love their extension system. It's really quite powerful. You use Sublime. Yeah, Sublime is good, but it's not free, right? So, all right, so let's try another game here. So great, let's go to the next great one. So Blitz. Run Blitz. Yeah, no, I'm sure Sublime is faster and lighter, but it's not free, right? And not that I mind, you know, buying software or anything. I definitely buy software, but I think that's, you know, for people who don't feel like paying, they get a pretty decent editor out of VS Code for free. Supported officially by Microsoft. Okay, so why am I playing this? This is not the game I wanted to play. Failed to load. Yeah, I know. I get it. Totally get it. Okay. I know why that wasn't working. I tried to load the PNG as a ROM. So it says, hey, by the way, I can't find the header I'm expecting, and oh, I can't load this ROM file, so. Do not load PNGs as ROM files. Okay, there we go. So basically what I'm trying to do here is I'm trying to see if I can get... Oh, we have an instruction mismatch. This is what I was looking for. So let's print this out. 18556 to mine. Also 18556. Okay, so we diff the logs. So the difference is on this long branch instruction. Okay, so mine ran for 6 cycles, whereas Vectrex ran for 5. Okay, so let me take a look. So I have a bunch of documents that I use to look at instructions. So this is one of them that I like. This one here is gives you the table of all the instructions, and it tells you, the addressing mode, how many cycles they take, how many bytes how long they are, how it affects the flags. It's pretty nice, and it's succinct. It also has some nice useful stuff at the bottom that I'm going to be using at some point. Like I saw this earlier. It describes how the interrupts are implemented, which I have yet to really implement properly, except for I think I only implemented the restart. So I need to do these NMI and SWI and IRQ and all that. So anyway, so let's take a look at LBRA. So yeah, LBRA is a 5-cycle instruction. I should have that in my opcodes. LBRA relative 5. So there's 5 cycles here. So then something else is adding a cycle. So this is pretty easy to debug. We'll just put a breakpoint in the CPU here. LBRA. LBRA is in table 0, while all the other long branch instructions are in table 1. So put our breakpoint there. And let's just run blitz. Okay, so here's a long branch. M cycles is 5, So that accounts for the instruction itself. Now if I hit F10 just to execute it, yeah, and there it became 6. So let's go take a look. Extra cycle if branch is taken. Ah, okay. Oh yes, okay, now I see. It's because I'm using this function op long branch for all the long branch instructions. So this is LBRA. These ones here are the long versions of branch never, branch of higher, branch of lower, or same. So I'm reusing this function. Let me go see something in the table. So we're looking at LBRA, but if we look at the other long branch, see these are on page 1. Yeah, so you see these say 5 or 6 cycles, right? So these are ones where if it took the branch, it'll take an extra cycle, but for long branch always, which it always takes the branch, there's no real condition to check, so looks like this one should always be just 5 cycles and not 5 or 6. So I gotta treat that one differently. Funny enough, the long branch, the branch never, which is basically a no-op, this also, it states that it would take 6 cycles, but of course it can't take the branch, so I guess this 2 should just be 5, right? Okay, so how should I... There's a few ways I could do this. I could just write a long branch always. I think that's probably the simplest thing here. And then no extra. Yeah, I think I'll just do that. Okay, that should do it. So we build this again. Oh, and I have something running. Right. Okay, so let's try this again. So for blitz, once again. Okay, so we got further this time. tackle. So we're at what, the 16-yard line or something? I think we didn't quite make it, but oh, nice. I think we made our down. First down. It's a pretty cool football game. Whoops. Okay, I'm pretty satisfied that this game is working the same way in terms of CPU. Well, maybe I could try to get a touchdown. It would be nice. Whoops. So now we're on the defense. Okay, never mind. Alright, I'm gonna stop here. Okay, next game. Cosmic Chasm. Let's try that one. So it's crazy. The OBS overhead that I get on this computer. So OBS, when I'm running it, it takes about 40% of my CPU, which is really quite high. And for the most part, that's because the transcoding is happening on my CPU and not on my video card, because I don't have a good video card. It's because of that, it doesn't leave me with a lot of CPU for my emulators here. But when I'm not streaming and I try the same thing, like these basically run at full speed. Or like at, let's say, 30 frames per second rather than like, what is it, 6 right now? Oops. So this is a pretty cool game. You're like this kind of, you're like a, I think you're supposed to be some kind of mining, drilling thing there, like some kind of vehicle. You've got this thing in the middle here that's just growing, and then you can go and use your drill. I'm not quite know how to do this, but there we go. So you want to know what kind of resolution? So this is it's pretty high res actually. I think it's streaming at, is it what, 1080? Yeah, I think it's a 1080 stream. So which is part of the reason why it's so slow, you know. As for my PC specs, like it's really old. It's an i5 running a really shitty old graphics card. I don't even remember anymore. It's some old ATI card. I could check. I think I have Specky here. Yes, I know that is why I'm using 40%, and I've looked into it. You know, I wanted to get like a graphics card that actually does transcoding on the GPU, and you know what? Thanks to Bitcoin mining, graphics cards, even like old NVIDIA cards that would, you know, GTX cards are pretty expensive. Let's see here. So I've got an i5 750, 4 cores, and for graphics, I've got a really old AMD Radeon HD 5670. So yeah, really old. But in a way, you know, I kind of don't mind having an old spec machine for writing this emulator, because it keeps you honest, you know. Okay, so this looks like it's working quite well. And you know, I could bring down the CPU usage if I like reduce the quality of the stream, but it is a programming stream, so I kind of want to, I don't want to like reduce the quality too much, because then you can't read the text, right? Which is one of those unique problems to coding streams. It's the best? Yeah, exactly. You know, so I mean, obviously it's a combination of things. I up my font size. It's like at like 120, which is actually definitely larger than I am normally comfortable with. Like I normally have my text like this at 100%. That's what I normally would use, but I don't mind, you know, zooming in a bit for the stream, and yeah, and keeping the quality high. Very important for this kind of stream. So, and those are the reasons why it's using 40% of my CPU. Yeah, for sure. If I could, hey, you know what? If I make money, if I ever make money on the stream, then I'll look into buying new parts for my computer. But like buying a new machine just for streaming right now, don't exactly need that right now, you know what I mean? Because it's totally fine. Okay, so next that I want to try was the Fortress of Narzad. So let's try that one. You know, another expense, you know, for me for streaming that I didn't have before I was streaming was basically I pay now for like unlimited internet. And you know, if you're Canadian, and I know Lisp Gamer you are now, right? You live here, you know that internet's quite expensive in Canada, like compared to pretty much everywhere else. So yeah. Like I pay basically an extra $15 per month for unlimited internet, which I pretty much need now that I'm streaming. So yeah, definitely there's that extra expense, and then I had to buy this mic, which was fine. It's a fixed cost, so. This is a really neat game. Your bullets pretty much bounce off the walls. You see that? Isn't that neat? And their bullets bounce off the walls too. And you can go up pretty high if I don't get shot. Paying 77 for unlimited. It's only 11 megabits, but it's always 11 megabits. Seems I don't know, seems a bit steep, but then again, nah, you know what? Actually, no, that sounds pretty. It's steep in general, and it's pretty much on par for what we expect here in Canada. Oh, really? Eh? 3 megabits up, 11 megabits down. Because I've got 30 down and 10 up, I think it is. I think I'm paying less than that, or about the same. Oh, okay. Yeah, definitely. You know, mine's not commercial; it's residential, so you know, the internet can go down. Although the downtime downtime percentage is pretty low. I mean, I suppose you expense it, right? Yeah. If one day I run my own business, I'll definitely look into that kind of thing. Heads up, action soccer. Let's do that next. Always looking for that mismatch. Check out this soccer game. You have a bunch of like dudes with like stick figure legs, and they run around the field, and isn't that cool? So here the low frame rate is causing many more lines to be drawn. That's why you see all this kind of crazy blurriness. Because what happens is that... wow, that was crazy. So the delta time, the frame time, is much larger than usual. And so what happens is that we end up processing more frames. So yeah, so what happens is that, let's say we get like a large delta time, and we end up executing more instructions than we would in a normal, say, frame. And so we end up accumulating the drawing of like multiple frames worth of lines in one shot. Hey, what's up, ABD? And so then, yeah, like, well, because what I'm not doing is I'm not saying, like, I'm not, let's say, what could I be doing? It's kind of like I'm simulating the render of multiple of the beam drawing lines in one discrete time step as though it was over a long period of time, and then after that, that gets sent to the shader, and so you see like many more lines on screen than normal. But this really only happens at low frame rates. And I could do things to kind of like, I was thinking about what I could do to mitigate this factor because it kind of like the overhead of drawing more lines actually makes it even slower, you know, so like running slow makes it run slower. And so ways to mitigate that would be, let's say, to limit the number of lines that can ever be drawn in the render. So right now it's really a lot. Like it's unlimited, it's unbounded. You know, as many lines as I accumulate is what gets drawn. I could say put a bound on that. But before I even do that, I was thinking I just need to optimize right now the way I do the line stuff. Because what I'm doing now is I just literally have a vector of lines. You know, a stood vector. No, it's not immediate mode. This is shaders. But I basically have, what I do is, let's say like the beam will usually move, let's say in a single line, right? Like let's say this one here. And what happens is that I'm processing the beam movement cycle by cycle, and as it's moving up here, I'm producing a single entry in my line buffer, as opposed to say building one large entry for all of this. You know what I mean? And I could totally optimize that. Like I just need to detect that while my beam is down and it's still moving in the same direction, just keep appending to the last thing I added to my vector line, and just make the line longer and longer. And then I end up with just one line to render, not like thousands of lines for one straight one. Just that alone should speed things up dramatically, I think. Because I know I profiled it, and I know a lot of time is wasted on the render side just transferring that kind of data, transferring the number of lines into, you know, I have this like line vector, and then that gets transferred into like the data that I need to send to the shaders. So just moving that much data, especially when my frame times get large, it just kind of exacerbates the problem. Okay, this game looks like it's fine. So hey BD, it's been a while since I've seen you. I'm just going through the games that are working to see if I can find any differences between my CPU and the Vectrex CPU using my desync detection mechanism. Let me try Hyperchase. Server. Client. See, like right now what happens is that I clamp my frame time to so that I basically run it 100 milliseconds maximally per frame, and so then I end up like in a kind of like a slow motion thing, you know? Wow, this game is a lot easier when I run in slow motion. I wonder if I remove the blur on this. Okay, this game is working. I still have this problem where I get this deadlock when the two of them want to quit at the same time, and it's because I'm doing some bad stuff with input management. So I need to fix that at some point. So many little things to fix. Okay, so Mindstorm, I've tested that one enough. We can try narrow escape here. Yeah, definitely. Never finished writing software. Oh yeah, this is the game we were playing earlier. Let's see if we can like not die. See, at the bottom I have like this kind of like gas thing, and I think if I need to shoot enough enemies not to run out. I really don't get this game. I don't know how to play it. I crash all the time. I feel like I think I'm gonna hit the people when I'm aiming, and I just don't connect. Sometimes I'll get a hit, but don't know. It just doesn't feel right. Oh, there, I got one now. See, why am I not hitting this one? Oh, and I hit the wall, I guess. That's another thing, I just don't feel like I should be hitting the wall. Or am I? See? I don't know. Alright, that one looks like it's working. See that this deadlock here. And then I'm like forced to kill one of the apps this way. And then that kills the other one. I mean, I even know exactly where it is. If I just, where is it? Is it the platform set focus? Is this thing here? I even tried with this mutex. None of this stuff even works. Set focus. Yeah, I watched some of Handmade Hero. I watched like say the first, I'd say 10 episodes, and then I'd watch like every once in a while I'd watch what he's up to in the latest streams. You know, for every few weeks I'll catch one and I'll watch where he's at right now. KC Muratori. Really good. I mean, I think he's doing a great job. Have you watched him? Try ripoff. Really? Really to what? Oh, you started from the beginning? You're watching his videos on YouTube? No, I think he is. I think it's very difficult, you know, starting from scratch and, you know, trying to teach. I think at the beginning he was really focused a lot on teaching the very basics. And I think he kind of shifts gears a little bit over time. But I think it's a very difficult thing to do, to say, hey, let's start from scratch and I'm going to show you every little bit of what it takes to make a game, you know? Including the mundane. Because if I'm not mistaken, does he? I think he does all of it on stream, or maybe I'm wrong. At least at the beginning, it seems so. I don't know if eventually he allows himself to work on stuff off stream. But like I do allow myself to work off stream, and in a way, it's kind of important because there's some stuff you just don't want people to watch you do, right? Like I know, for example, right now where I'm at on the emulator. You know, I think the CPU, we're pretty much honing in on getting the CPU to be just right. And we're really where my bugs are in the VIA chip, the interface adapter chip, which is basically think like rendering and joystick right now, and eventually sound. It pretty much all goes through this one chip that connects to a bunch of peripherals. But to get that right, and when I was developing it on stream, I was reading a lot. I think some of those streams are a little bit less interesting. Well, I guess it depends on the audience, right? But I feel like I need to do a lot of kind of reading again to just kind of refresh my memory and reload my brain with that information. And I'm not sure that's the kind of thing I'll be doing on stream, is just reading documents again, you know? So I'll probably just read them off stream. Just wondering, is he building a tangled mess? Why? Because he's doing it bit by bit? I mean, isn't that pretty much how most people write their engines? Kind of piece by piece as you need it. And if you follow some decent, practices and have enough experience, you don't really tangle yourself up into a knot too much. You know what I mean? Again, it's very hard for me to judge because I've really not watched much of Casey. You've already watched more than I have. Don't you put audio in an audio class, perhaps in a separate file? Are you saying that because he doesn't or didn't? He doesn't seem to. I mean, I think you're referring, because in the first, say, 10 streams or so, and I kind of liked what he talked about, which was, and I sort of actually took that idea in my emulator for having like the engine be the thing that drives the application. Yeah, so it is what you're talking about, yeah. So that is what I saw in the first 10 episodes, is that he's got this like, the driver, the thing where the main function is, that basically calls into these external functions that get implemented in the game at the game level. So there's basically a bunch of hooks and stuff like that, and I kind of like that. I know that he kind of puts everything in one file. I think eventually he probably splits it all out and does make separate files for things to organize them better. But more like that idea that you have this platform that drives, like this engine that drives everything, and the game layer just kind of gets these callbacks per frame, which is a bit different from the other way around, right? Which is you try to write the platform layer as a bunch of abstracted classes, and you have it, and the game has the main in it, and it just says, oh, I'm gonna create a window, and I'm going to create a joystick, and I'm going to have all these kind of abstract classes that are working together. And it's the other way around, and that's how actually I've written my old games and how I've seen a lot of engines written. But he makes a good point that it's actually really difficult to abstract those things, especially when you start dealing with the differences between platforms. And it's way simpler to just say, you know what, all the platformy specific stuff is just this one engine, and in the end we're just going to call into a bunch of hooked functions that the game implements. So it's just kind of flipping it the other way. So I've been actually trying to do that in this emulator. So like, I can actually show you what I mean. So if I go here, so I'm not sure I would do it that same way. So, I mean, I don't know exactly the same way. So basically I have this SDL engine class, right? And the idea is that, you know, the header file doesn't have any includes for SDL or anything, and all my SDL stuff is hidden inside the CPP file here. And right now it's not too big a file, but there are some things in here that could be split out for sure. You know, like I have some keyboard handling stuff, gamepad handling stuff, but all of this is SDL stuff. One thing I'm missing in here actually is the main. I actually plan to move it in here, but basically what we have is, let's see how does this work again? I don't even remember. Yeah, right now my main function's here, but this is probably going to move to the engine side. So I create this instance of the Vectrexy, which is called the client. I create my engine, and then I say register this client with the engine, and then after that I call run with the arguments. So I tell the engine to run, and then this is basically a function that only ends when we're done. And so it's in here that we do like our SDL message pump, you know, we poll and we handle input, we handle all that, and then the hooks are into this, I call it the iEngine client here, and these are the only hooks you have to implement. This is the game, right? So you have initialize, update, render, and shutdown. So that's pretty much it. And really, actually, this iEngine client here, he does these with just a bunch of external functions that he just implements, which is probably faster, because I'm actually paying like virtual dispatch calls for these. But I mean, these are called like once per frame, so I don't care. I don't do audio yet. I haven't done it yet. It'll come. But yeah, so there's a couple things that I'm not super happy about, but overall, like, so this is the engine client, and here you have some, like, you know, there are a couple of abstractions here, right? So I have the concept of a display, the concept of input, which is really joystick input. I have this concept of emulation events that are coming from the engine. And then I have a couple of these global functions that you can call from the game. So, you know, it's cleanish. So like one thing I didn't do was mix in all the rendering stuff in here. So I have a GL render, where is it? Yeah, here. So it's the GL render stuff here. And I mean, in here, I think I have some SDL. I don't remember. Wait, let me see, GL render, SDL. All right, so it's the engine that drives the GL render. Exactly. So see, I just moved this stuff out into, so like, you know, his audio code could easily and probably is eventually moved out into its own stuff, you know. Oh, hey, Benjamin. How's it going, man? Long time no see. So you're just gonna keep watching it, Lisp Gamer? You're gonna keep watching all his videos? Yeah, Ben, so have you, I think I saw you worked on your emulator not too long ago? He seems to hack a lot of things into globals. Yeah, I mean, I think, you know, so for me, I do have a couple of globals in here. Where are they? Yeah, up here. See, I have like, in my SDL engine, I have this anonymous namespace, right? And I have the client, the window, the GL context. So these are a few globals I have, right? And I mean, I'm not too concerned about it, right? Like these there really is only one of these engines in my whole thing, so it does keep things simple. But it would be no big deal for me to like wrap these up into a little pimpled class and make the engine. See, I have this engine here, which is a class, right? And I can do the same kind of thing that I did with, where did I do it? Oh yeah, for my CPU. So what I did for the CPU is I have the CPU class, and then I have a pimpled CPU implementation, which is completely hidden in the CPP file. So I could do the same thing and just put it in a class and then say, oh look, no globals. Done some Game Boy stuff. Haven't done much on Casio Loopy in a while. Got to get back into it. Yeah, I saw your really cool your work you did on the rewind feature, right, on your Game Boy emulator. Which I think I wrote to you on Twitter is something I did in my NES emulator that I was really proud of. You know what? I feel like I want to show you what it is. So this is my NES emulator here. So let's say I go to, where did I keep my ROMs again? A ROM somewhere. Oh yes, I think I know. Okay, so like this one here, Super Mario 3. Copy. That's path. Okay. So this is the emulator. You know what, I'm gonna stop my music because this does have sound. Oh, this might be a build that has a little slight bug with the sound, with the audio, but yeah, I think this is the one that I have a fix for this little. There's some glitchy sound here, but anyway. Can you hear that all right? So anyway, this is my NES emulator, right? So let's say we... where's my... So this basically, let's say, oh, you know, and then I hit rewind. So that's my rewind feature. And now it's not as sophisticated as yours. You do like a lot of compression, and I think you can keep it going for a really long time. For me, I'm doing no compression whatsoever, and I'm storing. I'm basically storing save states in a circular buffer that's large enough to hold 1 minute's worth of stuff, like 1 minute's worth of rewind buffer. So you can always rewind the last minute, basically, right? Just want to make sure, am I at the latest on this guy? Looks like I am. Let's see if this is the one that has no glitchy sound. No, it still has the glitchy sound. Anyway. Your Twitch is lagging? Actually, can you see if you have the option to change the quality of your stream? Because you should, I think. I haven't opened this in a long time. I'm like totally derailing now, looking at my NES emulator instead of Vectrexy. But this was the one that started it all for me. You know, my wanting to write emulators. I always wanted to write a NES emulator because I love the NES. Yeah, it's possible. Like I was saying earlier, my OBS it runs at 40% CPU usage for me. Oh no, don't worry about the derail, man. I don't care. It's fine. Like I said, I actually enjoy it. I love going over this, and this was such a fun project. Yeah, my CPU is like maxed out, like at 100% right now. It's crazy. Just want to build this because I want to see if, because I did make a fix, but I don't remember if I ever built the fix here at home on this machine. I worked a lot on this on my laptop, so I have this fixed timing issue by using the performance counter. I had some issue leading to some frame rate hitches, not using SDL get performance counter. So I was using SDL get ticks, which had a lower resolution, which was like messing things up. So I'll just let this build for a sec. So yeah, Benjamin, are you gonna get back to your loopy emulator? No, same crap. And yeah, it's probably because of my CPU being at 100%. It's just not able to run at full speed here. So that's why you hear all those little pops, because I'm not able to feed the audio buffer fast enough when my CPU runs under 60, which is what's happening here. I really got to do something about this OBS using 40% of my machine here. It's crazy. All right, so close this. Where were we? Okay, we tested ripoff. Let's test scramble across the two. Yes. I know there's some stuff I could have done to avoid the amounts of pops I get, like introduce a bit of latency and all that. But the thing is, most of the time when it's running, you know, without the CPU maxing out that way, I don't hear any pops whatsoever. So I'm pretty happy with the implementation I have. But yeah, as soon as like the frame rate drops, it doesn't. You know, it doesn't work that well. But I think that's really difficult anyways in general. You know, either you introduce a bunch of latency to like buffer up what you have and hope that you get back to good frame rates. But yeah, that's pretty much it, right? Oh, yeah. I gotta plug in my controller. But yeah, you know, implementing the audio side of my NES emulator took about as much time as it took me to implement the rest of the emulator. Like half my time was spent on audio. And part of that, of course, was the fact that I had never really programmed audio before, so it was like a lot of new stuff for me. You know, at least at that level. But yeah, even just emulating the sound, because I didn't look at any other emulator code. I was just reading the docs and trying to implement all the different chips, the DSP chips, the way they're described and stuff. And yeah, I kept, you know, I would get close and it wasn't quite right, and I would record WAV files from my emulator and then listen to them carefully, like analyze them in SoundForge and try to understand where things were going wrong. It was such a lot of work, but really enlightening, and still I was really happy when the audio finally started working. To Space Wars. See, my emulator takes about 20% CPU alone. Now I have two instances running, so each of them together take 40, plus the 40 from OBS, and then I have, you know, random 2% from like Chrome and other things, so I basically get to 100 in like no time. But when I, you know, play without OBS, I have definitely enough cycles, so things run a lot more smoothly. This game is funny. Space Wars is like it's basically Space War, and my ship is basically the USS Enterprise. You can see this one on the right here, and I've run out of gas, so now I just gotta and I run out of bullets. It's such a strange game. Isn't it awesome? Some of my favorite things to do is just play the audio and enjoy the chiptunes. Yeah, it is awesome. What was cool is that once I got the rewind feature into my own emulator, I just started playing a bunch of games and cheating my way till the end, right? Because I could just rewind at any moment, and I just finished a whole bunch of games. I think you wrote the same thing in your blog post. You should share your link here. I'll open it up so anyone who watches the video later could go check it out. It's a really good read. Okay, so Space Wars looks good. Let's do Spike. Yeah, so basically Benjamin here, or Benjamin, who's chatting here. This is his blog, and he wrote this really great blog post about how he implemented his rewind feature in his Game Boy emulator, BinGB. Really, really worth reading. He goes through a lot of cool stuff about how he implemented save state compression, and I don't want to spoil it too much, but look. Cool pictures. We love pictures. Yeah, but definitely worth reading. So if you guys want to check that out, it's binji.github.io, BINJI, and you'll find this great stuff here. And you can also follow Binji on Twitch. He also is an emu dev who streams. That's really cool. This is Spike. Really cool, like platformy 3D game. There's definitely still rendering issues there, like this ladder does not look right. And no problem, Benjamin. This is the game I need to implement audio for, because there's actually like digitized voice. So you'll hear them speaking. He'll say, "Darn it!" I don't know why I fall. Like, I don't see which ones of these are holes. Like, why is that a hole and the other ones are not? So you're asking if I'm working on multiplayer. You're asking because you see these two windows, right? So this is not actually multiplayer. Although the network, it is using sockets to connect the two and to sync them. But basically this is my desync detection. One of these has my CPU in it, and the other one has the CPU from the Vectrex emulator in it. That, you know, the one that I just hacked into my emulator so that I could compare. And what I do is every frame I hash like data from every instruction that just ran. So like which instruction, how many cycles, the memory reads and writes that occurred, a whole bunch of like information about the instruction itself. And I have this running hash, right? And at the end of the frame where I may have run some 40,000 instructions, the server will send the client, well, one will send the other, its hash, and then the client will compare the two, and if they're the same, it just keeps going, and if they're not, it stops and says, okay, there's a hash mismatch in the last in this last frame, which was this many instructions, and then at that point I dump the trace for that many instructions in both, and I compare them and look for the difference. Like, for example, the last time I found a difference was here. So this is like the big dump of one frame of instructions from both, and there was a difference in the long branch instruction where mine said it was 6 cycles, whereas Vectrex said it took 5 cycles. So that's what I've been doing. So now I've been going through the ROMs that are working to see if I can find more differences. So we found a few tonight. So that was one of them, the long branch. So yeah, it's basically a desync detection mechanism. Because I was having a hard time before where I would just kind of emit a trace dump from one, then run the other one and emit a trace dump, and then try to compare the trace dumps. Starting from the beginning, it would be fine, but if I needed to start dumping from somewhere in the middle, I'd end up with like, 500 meg dump files that were hard to line up and hard to compare. So this is way, way better. Yeah, I'm pretty happy with it. It's been really useful for, I fixed a whole bunch of CPU bugs because of it. Okay, so let's try Spinball. I know this one works, but we'll try it again. Oh, Lisp Gamer read your article. Yeah, it is really good. Well, thanks for hanging out, Lisp Gamer, and yeah, well, I'll catch you later. Why is this one running? Oh, I'm glad you were able to work on your project. This one's really weird. It like halts or something. Oh, okay. That's why. Just using the wrong inputs. Yeah, Wednesday. I'll be back online on Wednesday. So I'll see you on Wednesday, man. Yeah, totally. So I listen to coding streams in the background when I'm working. People think I'm crazy at work, you know. I can understand. It looks a bit strange, I guess. But it's I find it really fun seeing how other people solve problems, how they think. How they debug. I find that really probably one of the most interesting things to watch other people debug code and see how they try to solve those kinds of problems, you know? Because I feel like debugging, it's like one of those things that isn't taught a lot, you know? Like when you go to school and you learn about programming or you read books, it's all about writing code. But very few people tackle the very important topic of how to debug your code, right? So, you know, you kind of learn on your own. You start off with printf, and then, you know, you learn about a debugger and you learn tricks along the way. But even with that, you know, there's lots and lots of techniques that you can learn by watching people. So yeah, like, I hope that people who watch feel some, you know, that they're learning maybe some techniques of how I do my own debugging, trying to use my debugger as much as possible, breakpoints, hardware breakpoints, all that stuff, you know. Spinball, okay, Star Castle. Starting to get to the end of the list of ROMs that are working. That's pretty good. I really do think now the CPU is starting to stabilize quite a bit. Okay, let's try Star Castle. Yeah, this is a super cool game. The play control is really like slippery, and you got to be really careful not to go into the center there because you'll die. Now, of course, playing at 8 FPS is not going to make this any easier. Oh, shit, those things follow you? Can you shoot them? Your favorite technique is to write visualizers? Yes. Yeah, absolutely. Something that I learned a lot about working in games. Like for a long time, I worked on gameplay, like on character, camera controls, and writing like visualizations to understand what's going on. Drawing visualizations of like your speed over time as lines in the world and being able to look at them and to see if there's discontinuities, things like that. Really, really useful. Or like visualizing memory. Try Starship now. Alright. Oh wait. Yeah, okay. I think it was what happened is that my fuzzy matching for overlays ended up picking Star Castle for Starship because it just found Star and didn't find anything else. I gotta improve that at some point. So this is the right overlay for this game here. But it's funny how it totally worked for the other one. Yeah, this is weird. This game is pretty much exactly like Star Trek. The Star Trek game for the Vectrex, but they like slightly changed the ships and stuff, which I just think is hilarious. Kind of like trying to pass off this game as another one, but really it's exactly the same. These are normally like Romulan vessels or something. Alright, good enough. Come on. You know what? I said earlier that it was related to this deadlock. The deadlock actually isn't what I was thinking. I have a deadlock in my. It's not deadlock. It's I have like an infinite loop or a blocking call on my network code right now. I don't have any timeouts in there, and it's really badly done. But you know, it's not for production here. It's just for this desync detection stuff. So I don't really care too much. But at some point, if ever I use this code to do like network play or something, definitely I'll have to clean up that network code and get get all the timeout stuff done and not crash the emulator when when unexpected stuff happens. Here, let's try this guy. This one's in my good category, but that should be all right. So Star Trek here. So this is the game that the one just before is a ripoff of, or this is a ripoff of the other one. I don't know. Yeah, I think netplay would be fun. There are quite a few games that are two-player, but I don't know if they're really two-player, you know, like at the same time, so I don't think they're that fun. But there are a few. There are a few where you'll have two players on the same screen, like playing against each other, like that Space Wars one. That would be fun. See, this is pretty much the same game as before, right? Oops, not supposed to kill that thing. And finally, web warp. Graphics on the game are pretty good. You mean for the Star Trek one? Yeah, it's not bad. I actually own that card as well. On my actual Vectrex, I have the Star Trek cart and the overlay. It's pretty fun, but it gets pretty repetitive. See, this game looks pretty cool, right? This one I did not own. It's also really hard. Oh yeah, imagine 1982. Like so when I was a kid, right? I got this when I was around 1988. So by then it was about 6 years old. And I even had, I think I had already played the NES by then. So by NES standards, you know, it was different, right? Like I was impressed. Definitely impressed with the vector-based graphics, and the games were fun. But of course, you know, the main problem with this console and like consoles of this era, of this type, like Atari and all that, like 1982 and stuff, where the games were cool, but you know, the ultimate goal was just high score because they were based on arcade games. And I think that was one of the biggest things that happened during the course of the early NES era, like around 1987, 88. We start to get games that were just much longer in scope. You know, once Zelda came out, then you had like, you know, Castlevania 2 and all these games that were, you know, more progression based and not score based. And that pretty much changed everything. So then it was hard for me to like go back to games like this. But for like really quick, you know, just feel like spending 10 minutes just trying to shoot, or like skill-based games, these are pretty fun. Okay, well, that one works too. So that pretty much brings me down to the end of this list, which is the commercially released ROMs. Those are the ones I've been testing. Now, apart from those, I have a couple of good I can take a look at, like Berserk. I won't check out the Mindstorm ones. Okay, let's just do Berserk. That looks like the last one that I haven't tried really. Did this not die yet? It is going to be fun though to get some audio on the Vectrex. The audio is really it's pretty cool, and games like this really use the audio well, I find. They're like they came up with some pretty neat sound effects for this game when you kill dudes. So this is another one that for which I own the cart. That's why I know it well. Like this game, you know, you get the impression of progression. You're like, wow, you know, you're going through this maze, you got screens, but again, every screen is random. So then again, it's just about score. It's a game where like you're basically shooting robots, and then if you spend too much time on one screen, there's this bouncy hexagon or something, or octagon, I forget. I think it's an octagon that like comes after you and you cannot kill it. You must leave the screen or you die if it touches you. I'll see if I can make it appear. We'll just wait a bit. There it is. Yeah, so this octagon face dude, it just bounces around. Okay. So we've run through pretty much all these games that run, you know, pretty well. I mean, I have a bunch that don't run yet, but the ones that have good or great next to them, we compared them all. We fixed a few bugs tonight, so let's see. Yeah, so we fixed the long branch one. I think I was off stream, but I fixed the sub with carry. This happened though off stream. So I mean, combine that with the ones from last stream where we fixed increment and rotate left, and rotate right. And yeah, we fixed quite a few CPU bugs, and there may be more in the future as I get more of the games online. But yeah, I think I'm starting to wind down on CPU stuff. So this is fix or taking 6 instead of 5. Yeah, pre-Robotron. So I mean, I think Berserk actually is an arcade game. A lot of these games were released in arcades. Okay, I'm going to push this up. So looking at this list, so all the stuff that says VIA not implemented, these are things I was saying I need to kind of refresh my memory and reread some docs on the VIA again and get back into the place where I can start working on it, because my head has been totally in the CPU side. So I got to go back to this VIA chip implementation. There's a lot there, so I'm just gonna spend some time reading stuff and start looking at implementing these things, like interrupt enable. It's not implemented at all. I don't know what this is about, but anyway. A without handshake not implemented, so that's another thing I need to look at. Okay, those are the only ones. So I have a bunch of no boot. So those I could debug as well, like try to see what's going on. What is the... I could take any of these and then like look at the dump and see what it is that the code looks like it's waiting on. It's probably like reading something from, I'm gonna guess it's reading a register from the VIA chips, and waiting for some flag to be set or something that I haven't implemented yet. So those are the no boot ones. Some of these are just plain bugs, like this invalid read here that I'm getting, and I'm getting it on the Vectrex as well. So when you see Vectrex same here, so that's how, like, I went through these. I used to worry, like, wonder, is this because one of my CPU instructions isn't implemented correctly, and as a result we're, you know, spinning off into memory we're not supposed to. So I ran them against the Vectrex, and Vectrex would do the same thing. So if it happens with the Vectrex CPU, we can conclude that the problem isn't the CPU implementation, you know? So that's what this means here. So this is probably, again, a VIA implementation problem that leads to this invalid cartridge read. Or it's the ROM. The ROM itself does invalid reads in cartridge space, and like on real hardware it doesn't really matter, because we have a few of those as well. I have some missing ops. So like these two I could do. I could implement some of these. So like SWI and CWAI, these are interrupt related functions. I mean, I think those are pretty much the only two. If we go back to this document, see, these are the interrupts that I need to implement. So here's SWI. What was the other one? CWAI. I don't even know what that means. CWAI? Oh yeah, I gotta go look that up again. And CCR, wait for interrupt. So yeah, there's that one. And then there's a software interrupt 1. So I could implement that, which shouldn't be too hard. It's basically E, F, I. What are E, F, and I? I'm guessing these refer to flags. Key. No, unrelated. Yeah, not quite sure. Just maybe understand what this actually means here. And then after that, you see it even tells you how many cycles. So this should be pretty easy to implement. And then we can like unlock the SWI ones. Here we go, software interrupt. Operation set E, entire state will be saved. Set E. Set I, comma F, mask interrupts. Okay, so it's these flags here. Entire. Okay, there we go. That's E. That's F, and then that's I. These are just flags in the condition code register, in the flags register. So that's what it's referring to. So we set that, we go ahead and we do this, then we set these two. We set the PC to FFFA because that's where we're going to the address stored at FFFA and FFFB. So we set PC to that because that's basically what SWI1 refers to. It's this vector table at the end of the ROM. And then all of the inputs are pushed onto the hardware stack, accepting only the hardware stack pointer itself, and control is transferred through the SWI vector. Yeah. SWI sets I and F bits. I'm supposing then once we implement this, we need to implement the return from interrupt, which I don't think I did. This one here, RTI. Yeah, for sure I'd have to implement RTI. So I did not implement that. Let me just look at RTI. So that must do the undoing of some of those. Here we go, RTI. Here. So return from RTI, and then it says if the CCR bit E is set. Okay, so that's how it knows that the entire state was saved. So if the entire is set, we go ahead and pop the entire state. Hey Blue Dragon, how's it going? If CCR bit E is clear, that means that only the return address has been pushed, not the entire state as well. Then condition codes recovered from stack, yeah, so that gets back. Okay, so since we push the condition codes to the stack, whatever was on there before gets completely restored, so we don't have to do any clearing of E or F or I. Yeah, so we should totally do this. I think I'll work on this next in a couple days on Wednesday. We'll implement the SWI and RTI and start getting these interrupt handlers. So this way, all these, like the few here that actually have the unhandled op, we can just get those guys working, and yeah, we'll get another version of Armor Attack working. We'll get Bedlam. Bedlam hasn't worked because of, oh no, that's not the right one. What will we get? We'll get this different version of Fortress of Narzad. I mean, I guess we won't get many games because not many games are using this interrupt, but still, we should do them anyway. And there may be other games here. I haven't tested all of these, right? Probably a lot of these games are using these interrupts. So, so yeah, Blue Dragon, you kind of joined around the time that I'm going to be logging off. So, just finished drawing practice for the evening. Oh, that's cool. So yeah, there's that, and then there's this CWAI. Let me just want to quickly read about that one. I think I read about it once, and I was like, wow, looks kind of complicated. Clear and wait. Okay, that's what it stands for. Clear and wait for interrupt. Oh, don't worry, man. You can catch me on Wednesday night. So it takes a condition code register and sets it to that ANDed with whatever memory location we gave it. The CWAI instruction ANDs an immediate byte with the condition code register, which may clear interrupt mask bits. It stacks the entire machine state on the hardware stack and then looks for an interrupt. When a non-masked interrupt occurs, no further machine state will be saved before vectoring to the interrupt handling routine. You started practicing when the stream started? So next time you just gotta log in and put me in the background. There's nothing like drawing to the calm sound of my voice. Okay, so this sets E, stores the state. FF equals enable neither, enable IRQ, BF, enable FIRQ, AF, enable both. Yeah, I don't completely understand what this is about. So I get that we read a byte from memory and we AND it and overwrite our CCR with it here. I get that we save the entire state. Not sure what this refers to. FF, EF, BF, and AF. It stacks the entire state machine and then looks for an interrupt. What does that mean? Looks for an interrupt. When a non-masked interrupt occurs, no further machine state will be saved before vectoring to the interrupt handling routine. Okay, so for the masked interrupts, they're talking about interrupt mask and fast interrupt masked. Here, so these bit fields. Looks like example immediates for CWAI. So I'm guessing here what it means is that since we've already saved the state and we're waiting, as soon as an interrupt occurs, a non-masked interrupt occurs, we don't need to save the state anymore because we've already have. And we immediately vector, like we immediately jump to that specific interrupt handling routine. So I mean, I guess and then it looks for an interrupt. Oh, the table I was looking at earlier. Okay, video delay. Sorry, yeah. Looks like example immediates. So you know what? I'll read more about this. Definitely we can do the SWI, and then while we're at it, we'll probably do 1, 2, and 3 just for completion's sake. And and then I'll look at how this one works. I'm not quite sure. I need to read a little bit more about it. So we can do that, and in the meantime, I'll kind of refresh my memory on how this chip here works. 6522. So yeah, I'm going to stop it here, guys. So thanks a lot for watching, and I'll be back online in just a couple nights, so hope to see you then. Thanks for watching, guys. Take care.